Good morning, everyone. Let's try that again. Good morning, everyone. Good morning. Perfect.
Hey everyone, Donovan Brown here with an update to my Coded UI series of videos. I would like to thank everyone who watched and commented on the previous videos. In this video, I will answer some of the questions posted. For example, how to data bind to a Coded UI test post Visual Studio 2010, which is very different. I will also detail the 3 techniques you can use to create a Coded UI test, including action recording, Coded UI test builder, and now my favorite way, 100% code. Don't be alarmed. The code you have to write is not very complicated. And as always, I will try to highlight areas where Coded UI will not perform as expected and how you can tweak your recordings to achieve the desired results. So with that said, let's jump right into the demo. I will begin with the tour of the application we are going to test. It is a simple MVC ASP.NET application that allows CRUD operations on a person object. Our goal is to automate a test that can verify this functionality. Now let's turn our attention to Microsoft Test Manager. This tool allows us to write and execute manual tests. The reason we are talking about it in an automation talk is because Microsoft Test Manager has a feature that can aid in the creation of a Coded UI test called an action recording. An action recording captures all the actions we take and stores them in such a way that Microsoft Test Manager can play back those actions. This information can be shared with Visual Studio to create Coded UI test. So let's begin by running the manual test. Make sure you check the box labeled Create Action Recording before you click the Start Test button. Checking this box instructs Microsoft Test Manager to track your actions. You can monitor the actions tracked by expanding the Actions panel at the bottom of the test runner. It is very important when creating an action recording to pass each step after completing the actions for that step. Passing the step after completing the actions is how Microsoft Test Manager associates the actions with a step. One feature I want to take a moment to discuss is intent-aware recording. If you watch the action panel, as I navigate to the website, you will see it in action. To navigate to the website, I must first click the address text box and type in the start of the address. Then use the down arrow key on my keyboard to select the suggestion and press enter. However, the resulting action is simply go to web page. Intent-aware recording was able to determine that my intent was to go to the web page, not the actions it took to get there. I wanted to point this out so that you don't wonder why you don't see the exact actions you performed in the Actions panel. In the background, Microsoft Test Manager is creating functions for each step with the name of the text in the step, so you can recognize each step in the final test. Because we used parameters when we created the test case, we are now being presented the values for this iteration. We need to associate the parameter value with the user interface control to be populated. To do this, simply left-click the value from the test runner. Left-clicking the value will copy it to your clipboard. Now paste the value using the Ctrl+V command into the correct UI control. When you pass the step, the tool will bind the value to the control. After binding the parameter, if you were to change the values of the parameters or add additional iterations, Microsoft Test Manager will be able to populate the controls with the correct values. We are now going to simply complete the steps and click End Iteration. This will instruct Microsoft Test Manager to save the action recording. After I create an action recording, I like to play it back to make sure it was recorded correctly. So I will delete the row I just added and play the test to verify. To play an action recording, simply select Play All from the Play menu to execute the entire test. You can, however, select as many or as few steps as you like and click Play to only play the selected steps. Now, I will clean up the new row and save and close my test case. Now we can close Microsoft Test Manager and turn our attentions to Visual Studio. First, we need to create a new Coded UI test project. Once the project is created, we will be presented a dialog box with options on how to create our test. Option 1 is to use the Coded UI test builder, which we will look at in a moment. Option 2 is to use an existing action recording. And option 3 is to simply click Cancel and write the entire test and code from scratch, which we will do last. But for now, select option 2 and click OK. Now we need to locate the test case that has the action recording associated with it. In the Work Items Picker dialog, I will simply search for a test case that has the word person in it. From the results, I will select test case 263 and click OK. Visual Studio will read the action recording and generate the code for the coded UI test. Before we modify the test in any way, let's first run the test to make sure it works as expected. Now that we know the test is working, we are going to use the Coded UI Test Builder to add validation and additional steps. To add validation or additional steps to an existing test case, simply place your cursor in the desired location, right-click, and select Generate Code from Coded UI Test, then use Coded UI Test Builder. This is the same experience we would have had if we had selected option 1 from the original dialog. The Coded UI Test Builder has 4 buttons: the Record and Pause, Show Recorded Steps, Crosshairs, and Generate Code. Use the Record and Pause button to control when to have your actions recorded or not. All the recorded actions can be reviewed and modified from the Show Recorded Steps button. This can be very useful when you make a mistake and don't want to have to start all over. You can simply delete the actions you did not want recorded. The crosshairs are used to locate controls on the screen and display information about them. We will use this tool shortly to add validation to our existing test. The final button will take the currently recorded actions and group them into a function. To begin adding validation to our test, we first need to open our application to the correct screen. Now we can use the crosshairs to inspect the first column of the second row of our table that currently has the name Donovan in it. Left-click and hold the crosshairs tool and drag it over the desired control. Once the control has a blue box around it, you can release the mouse button. The properties of the selected control will be displayed above the Coded UI Test Builder. Here you can inspect the properties and add validations. To add a validation, right-click the desired property and select Add Assertion. Select the appropriate values and click OK. Next, we need to generate code so we can name our validation function. While we have the Coded UI Test Builder open, we're going to add 2 steps to our test to delete the second row of the table. As you can see, the Coded UI Test Builder added the new code to our original test case right where we placed the cursor. Let's run the test to verify everything was generated correctly. One advantage of adding parameters to your manual test cases is when you create an action recording, Visual Studio will automatically be data bound to the test case. When we change or add values to the test case, the Coded UI test will use the new values the next time it is run. Let's change the values in the test case we used to create this Coded UI test. Because we have validation on the first name, we need to update our test to use the correct values. We can data bind the validation value just like the values we used for entering the first and last names. When the verified first name function was generated by the Coded UI Test Builder, it also created a property we can use to set the value to be validated. We will use the same value used for the first name pulled from the test case. I know from experience that when the inner text is read from the cell, it will have a trailing space, so I'm going to add that now and rerun the test. As you can see, the test picked up the new values we entered in the test case. Although we updated the validation value, the test still fails. Issues like this one are why I prefer to write my test entirely in code. You can avoid issues like this when you are in complete control. This issue is a result of aggressive search properties. Search properties are values the Coded UI test uses to identify certain controls. If the search tries to be too specific, it can sometimes cause issues. The problem here is caused by inner text being used as one of the search properties. When we selected the cell to create our validation, it contained Donovan. And now the test will only find the cell if it contains Donovan, which defeats the entire purpose of data driving a test case. Because the test failed, the row was never deleted. So let's clean that up now. Luckily, this issue is very easy to correct. All we have to do is double-click the UI map in Solution Explorer. The UI map is displayed in two sections, the actions and the controls. When you select an action on the left, it selects the control it uses on the right. With the correct control selected, we can examine its search properties. To correct this issue, all we have to do is remove inner text from the search properties of this control. With the search properties corrected, the test now passes as expected. In the final section, we are going to recreate the test entirely in code. So to begin, let's create a new Coded UI test and click Cancel on the Generate Code for Coded UI Test dialog. We are going to be using a lot of classes in the HTML controls namespace, so let's add a using now. The first goal of our test is to start IE with our application loaded. This can be achieved using the launch method of the browser window class. The browser that is returned from this call to launch is very important, so we store it in a variable. All the controls we are going to be looking for will be scoped to some parent. The browser will be the parent for the majority of the controls we need to find. Once our application is open, the first thing we need to do is click the People link. Therefore, we need to determine properties we can use to identify that control. Press F12 to bring up the developer tools of IE so that we can look at the structure of the web page. The developer tools show us the inner text of the hyperlink is people. We will be able to use the inner text to locate that control. Once we click People, we then need to click Create New. That will take us to a form where we will need to enter text into text boxes and click the Create button. Let's use the developer tools again to see how we can identify these controls. The text boxes have IDs that identify them, so we will use the control's ID to locate them. Finally, let's look at the button. We are going to use the value attribute to locate it. Armed with all this information, we can start writing the code. There are several places where we need to click a link, so we're going to write a function that can click any link given the parent and the inner text. The parent of all the controls will be of type UI test control, so that will be the type of our first parameter to our function. Next, we need a string that will contain the inner text to search for. Step 1 is to create a new hyperlink object scoped to the parent. Then we use the search properties to add the inner text. Now that we have the link located, we simply want to click it with the mouse. With this function, we can now click any link, so let's use it to click People and Create New. The parent of these two links is simply the web browser. After we click the Create New link, we will be on a page where we need to enter values into the text boxes. We are going to write a very similar function to Click Link that takes a parent, ID, and value to be typed into the text box. Once we locate the correct control using the ID, all we have to do is set the text property of the control to the desired value. Now let's use this function in our test to fill in the form. The last step to creating a person is clicking the Create button. So now we will create a function that can click a button given its value attribute. Once we locate the control using the value attribute, we are going to click it using the mouse. At this point, if we run our test, we should be able to create a new person. Perfect. Now let's see how we can delete that row. Remember, all controls must have a parent, and to this point, all of our controls have used the browser. However, if we were to pass the browser as the parent and ask it to click the delete link, which delete link would it click? The one in row 1 or the one in row 2? Let's use the developer tools of IE to see if we can find a better parent for our delete link. The tools show us that all of the links have a table cell as the parent object, but unfortunately, the developer tools do not show us any way to identify that cell. Instead, we are going to rely on the Coded UI Test Builder to help us locate that control. To open the Coded UI Test Builder, we are simply going to right-click the UI map in Solution Explorer and select Edit with Coded UI Test Builder. With the Coded UI Test Builder open, use the crosshairs to locate the cell that contains the links for our row. The Coded UI Test Builder shows us a lot more information about the cell than the developer tools. Notice that each cell of the table is identified by its row and column index. These are the values we will use to locate a cell. We not only need to locate a cell for the links, but we also need to validate the values of the names. So let's create a method that can return a cell given the parent, row index, and column index. The cell will be the parent that we pass to click link to find the delete link. One slight difference of this function is instead of returning void or nothing, this function will return the cell it finds. We will be able to store this in a variable so that we can use it to pass to click link. Before we delete the row, let's verify that the row was created correctly. To do this, we need to get the first column of the second row and examine its inner text. We can use the getCell function to get the cell, then use the assert class to test the value. We are going to pass the browser as the parent and enter a zero-based index of the cell row and column. The assert class functions will fail the test if they are not true. Now we can grab the last column of the second row and use that as the parent when we want to click the delete link. Let's go clean up from our last run and run the test again to verify everything works as expected. The final thing I want to show in this video is how we can data drive the test with a CSV file. Let's begin by creating the data source. To the project, add a new text file named data.csv. This will be a comma-delimited file that contains first, middle, and last name. The key here is the encoding that we use to save the file. From the File menu, select Advanced Save Options, and then select Unicode UTF-8 without signature. Now we can save the file. The last thing we have to do to the file is make sure it gets copied to the output folder. Just right-click the file in Solution Explorer and select Properties. Change the Copy to Output directory to Copy Always. Now we need to connect the file to the test. We will do this by adding the deployment and data source attributes. The deployment attribute makes sure that the file is copied to the folder that the tests are executed from. The data source attribute describes the class to use to load the data, the location, table, and access method. Please pay close attention to the format of the location and table. The use of the pipe and hashtag characters is intentional. Finally, we will use the data row property of the test context class to access the data from the data source. We will use these values for the first, middle, and last name. We also need to data bind the call to the assert class. Now run the test again and verify we have done everything correctly. I hope this video has shown you just how powerful the coded UI tests are and ways that you can incorporate them into your testing effort. Until next time, I'm Donovan Brown.